Okay, so in this video, we will be discussing about pragma in cyber workbench or high-level synthesis. This video will only focus on cyber workbench, but the same logic applies to any other high-level synthesis. Only difference is keyword. So what we have is C code when execute includes standard IO library. Otherwise, when we need to compile and synthesize, they are not being used. If not C, we define input output and main process without any pragma is called main, and we do bubble sort algorithm. There are no pragmas here in this design, and therefore when I look on the report quality of result, we are using the default design CyberWork provides uses 783 ALUTs, 75 registers, and 16 latency with about 21 or 22 nanosecond of critical path. Turns out to be 45 megahertz. And the data path is here with 16 latency. So this is what our circuit looks like once synthesized without any pragma. Now, what I've done is I've copied the function and provided pragma for design one, which is using RAM for the bubble sort array. Second pragma is unroll all for the original for loop. And then when doing the sort for data number of array on the adjacent pin or adjacent value, we're doing all unroll. So both unroll all with forcing to use RAM for the binary array. And the name of this file or design is design one because it's model one. Once synthesized, quality of result, our latency increased significantly from 16 to 66, and critical path decreased to 8.88, and then lookup tables used are also decreased to 438, and register count is significantly increased from 16 to 73. Was it 16? No, 75. Sorry. So it's slightly decreased, which is which means our design seems to be using lower area compared to original, but it's much slower because we have 66 latency, and therefore it could be cheaper, but depends on the application. Now, at the same time, I've also copied the function and changed the pragma to use register instead of array. And I've also changed another pragma to unroll 0 time. That means we do expect high latency, but we will see how the register compared to RAM affects our circuit. And name of this design is design model 2 or design 2. Once synthesized, let's look at quality of result. So, of course, it uses even smaller lookup tables, 21 registers, 64 memory bits. Originally, we had zero memory bits. Uh, so there are trade-offs. When lookup tables are lower, the memory bits are increased higher because we're using registers. Uh, 21 registers are also much smaller compared to what the original design had. We had about 75. But our latency increased significantly compared to design model 1 as well as original design. Originally, we had 16. Our design model 1 had 70, no, 66. And now we're saying 72. And of course, it means critical path per delay, well, critical path per worst case is 4.75, but latency is much higher. So circuit is still slower, could be not as slow as previous. May have to find the actual critical path and how it affects. But in general, it's much area concentrated compared to original circuit. And when we look at the data path, it is definitely a, I don't really know how to explain, but it's definitely more shows more latency on both steps. We have too many of wirings and connectors. Same resources are being used multiple times because of the way they're routed here. Actually, let's compare with design one as well. So this circuit is kind of similar, but like we discussed, they're using RAM instead of registers. So we do see a smaller count for input and the block here. When we compare with the register, we do expect high register count. Well, register 4, 3, 0, 1, 2, 3, 4, I suppose. So yeah, they are being shared multiple times with mux or different hardware arrays. Now, for the third design model, I'm using register and I'm allowing to use all the unroll count. So we do expect faster response, but we shall see about latency. That area will be more focused now. Hmm. So quality of result, 783, 75, and 16 and 21. I believe that's same as, yeah, 783, 75, 16, 21. So apparently us or me putting pragma for register for the input and then unroll all makes no difference compared to not putting any pragma, because by default, design 3 is same as our main when we did not use any pragma. It's definitely faster, or at least has lower latency index, but it seems to be using more lookup tables and registers, 75 register count and 783 lookup tables. It does not use any memory bits or DSPs, which is good. And when we look at the data path, yeah, I was expecting kind of same. It's same, much smaller because we have dedicated resources, lookup tables. So it requires less steps or latency. Circuit is smaller, less resources are being shared or not shared at all. But it may be taking more area for each hardware block here. So there will be always trade-off depending on the application and the purpose of the design. And it's definitely impressive how Cyber Workbench, without any pragma, gives the ideal circuit. I won't say ideal, but the good circuit, which I would have wanted. So that's pretty much it.